So the two proportion z interval uses the following formula: p hat 1 minus p hat 2 plus or minus the z-score you find by doing inverse norm at whatever confidence level you're given in the problem, times the square root of the quantity of p1 times 1 minus p1 over n1 plus p2, p hat 2 times 1 minus p hat 2 over n2. And p hat 1 and p hat 2 are just the two population proportions that you calculated from the problem. So for example, if say 20 people said yes, 60 people said no for the first sample, that would be 0.25 as your p hat. And N1 and N2 are just the sample sizes of the two samples respectively. And this interval is important because if 0 is in the interval at some point, that means that you can't conclude that the two proportions are different or the two samples were different at whatever confidence level you chose. But that being said, if 0 is not in the interval, then you can be safe to conclude that the two populations are different at the confidence level you calculated the interval at. The two proportion z-test is also useful. One thing you'll notice about this formula is that it has p1 and p2, and those basically cancel out every single time, so you don't have to really worry about that part. And also, you might notice that it has pc there, and that's the total population proportion. So for example, if in population 1 you had 20 out of 60, and in population 2 you had 10 out of 60, the total population proportion would add up to be 30 out of 120, or 0.25. And your random, and normal and independent conditions are still exactly the same. N times p hat must be greater than 10, and n times 1 minus p hat must also be greater than 10. And then your independent is just a 10% rule, so make sure that the total sample size, the total population size, is greater than 10 times the sample size. Now, on your two sample t interval, you're going to use this formula, x var 1 minus x var 2 plus or minus the t-score you found by using the correct degrees of freedom and the correct confidence level. And then you're going to multiply that by the square root of your standard deviation of your first sample squared over n1, size of your first sample. And then you add that to the standard deviation of your second sample squared, all over n2, get the square root of that value. And then that you calculate your interval from that. And then yet again, the interval has the same importance that was explained for the z interval. Now for the t-test, you use this formula, and yet again, mu1 and mu2 will cancel out, so you don't have to worry about that part of the problem. And overall, they're pretty similar equations here. It's just find the difference in the two sample means, and then dividing that by the deviation, the standard deviation. And the conditions for the t-test are random, independent, and normal again. And then random is going to be stated or implied in the problem. And also it's worth noting that if the problem states it's a randomized experiment, then your random and independent conditions are both met by that. And then for normal, n must be greater than 30, and then you can use the central limit theorem and assume normality. But if n is less than 30, you must make some sort of plot, like a dot plot or a box and whisker plot. And then if there's no outliers, or if there's no obvious skew, you can feel safe assuming normality.